Okay, fine guys, so here the self practice 3.2 and here we are going to practice a volume question, and here I have already given the answer. Just take this. In the first one, the diagram shows a solid hemisphere with radius 2r. So you can see that the radius, they have given the radius of this hemisphere, and that's 2r. And further, find the volume of the hemisphere. So how to calculate that? Here the formula 435r cube into half, because it's a hemisphere. If not, you can mark directly 2/3. That's not a problem. Okay, right. So now 4/3 5, and the radius is 2r. That's not just r, this time it's 2r, so that's why I substitute the value 2r there to the power 3. And so thereafter we can simplify that. 3 to 2 we can cancel, then 2 is there, so I mark that 2 5, and 2 to the power 3 means 2 into 2 into 2, and the answer is 8 r to the power 3. And now we can multiply them both. 2 8 is 16, 5 is remaining, as well as r to the power 3. So there the volume of the hemisphere. So the first one is clear. And they have given another small statement, just we'll read that. A right cone is carved out. So you all can see that a right cone is carved out from the hemisphere symmetrically about the center of the flat surface with diameter equal to half the radius. Okay, so again, center of the flat surface with the diameter, that means the diameter of this cone is equal to diameter equal to half the radius of the hemisphere. Half the radius of this hemisphere is r. Half the radius is r. That means that r is equals to this diameter, the diameter of this cone. Okay, fine. So what is the radius of this? That's r/2. You got it? Read again. A right cone is carved out from the hemisphere symmetrically about the center of the flat surface with the diameter. The diameter of this cone is equal to half the radius of the hemisphere. Half the radius of the hemisphere is r. So the diameter is r, then the radius is r/2. That's what I have marked here. Okay, and they are asking us to find the volume of the cone in terms of h, r and phi. So here it is 103 phi r squared h, that's the common formula. 103 phi, just let it be, and the radius of the cone is now r/2, and square is still there, and the height is still h. Okay, now we'll simplify that. 2 square is 4, and 4 3s are 12, and phi r squared h. That's it. So the second one also clear. And now they are asking us to find, they're asking us to prove something. We'll read that slowly. If the volume of the if the volume of the cone is, C must come there. If the volume of the cone is, right, volume of the cone is 1 over 256 of the volume of the hemisphere. That's what they have said, right? Cone is 1 over 256 times of the volume of the hemisphere. So we have, it's better to mark like this, then easy for us, right? So the volume of the cone, already we have that, phi r squared h over 12. Is means equal sign. 1 over 256 of means into, and the volume of the hemisphere, that's also we have that, 16 phi r cube over 3. And now we can simplify this easily. 16 to 256 we can cancel 16, and 16 3s are 48. And now we can take this division 12 to the right side, and there will be multiplication 12. You can see that, right? So and we can cancel the 5 as well. 5 to 5 has been already cancelled, as well as 2r's to 2r's. So another r is remaining in the right side. So that r is what I have marked here. And division 12 will take that to the right side, and there will be into 12. And now we can divide them. 12 to 48, if we divide, 4 is remaining. So r/4 is the answer. Okay, so h is equals r/4. We have proved that.
Okay guys, so the second question, the height of a solid right circular cylindrical metal block of radius 10.5 centimeter is 20 centimeter. Okay, so they have given the data of a right circular cylindrical metal block, right? And the next, when this cylinder was heated and 25 identical solid metal spheres were made, 230 cubic centimeter of metal were left over. Okay, right, I'm drawing a small rough sketch. You can see that here. So there's a small cylinder, okay, no? And after that, by heating this, right now they are making about 25 identical spheres. Okay, then after making those 25, they're receiving another 230 centimeter cube of metal left. Okay, so now here listen, calculate the volume of the cylindrical metal block. So we have to go with this formula phi r squared h, right? So phi r squared h, that's a formula of the cylinder, Okay, right. So the substitution of phi is 22/7, and the radius here they have given is 10.5. So instead of 10.5, we can take the rest 21/2, again 21/2 into 20. Fine. So now we can cancel this 2 to 22. Then 11 is what remaining, and 7 to 21 also can cancel, then 3. Okay, that's it. And now you all can see that 2 to 20 also can cancel, then it's 10. Right, so we'll write the remainders 11, 3, 21 and 10. Now 11 3s is 33, 33 21 is 693. If we multiply by 10, we will get 6930 centimeter cube. So that's the volume of this cylinder. And now they are saying that when this cylinder was heated and 25 identical solid metal spheres were made, 230 of metal were left over. Okay, right. So the second question is about what's the volume of one sphere. So to calculate the volume of one sphere, what we have to do, first of all, we have to subtract that the remainder 230. Then we will get the volume used to make the spheres. So what's the volume they have used to make the spheres? That's 6700 centimeter cube. And the total is 6700. Then to calculate for one, what we have to do, just we have to divide that by 25. Then we will get 268 centimeter cube as the answer. And now we'll read the third one. If the radius of one of the spheres that was made is denoted by simple r, by assuming that phi is equals 3.14 and using the logarithms table, find the value of r to the power 3 to the nearest whole number. Okay, right. So here listen. They are saying that the radius of one of the sphere that was made by is r. Okay, they have given the radius of one sphere and that's simple r. Okay, and they are asking us to substitute 3.14 for this phi and to calculate the value of this r to the power 3. Okay, right. So we'll start. The volume of the sphere is equals 268 and here the formula of that. So now I am taking the rest to the right side. Division 3 if we send that, there will be multiplication 3, multiplication 4, there will be division 4, as well as phi also, they'll go down to the denominator. Okay, now we'll multiply them both. 3 into 268, it's 804, and 4 if we multiply by 3.14, we'll get 12.56. And now it's a bit difficult to simplify, as well as they are also asking us to use logarithms. So I applied the logarithms. Okay, so logarithm 804 minus, and the second one is log 12.56. And now we'll find the logarithm of 804. And how many whole numbers are here? 3. Then 3 minus 1, it's 2. That means the characteristic of this is 2. And here how many whole numbers are there? 2. Then 2 minus 1, it's 1 point. That's it. And 84, the logarithm is 9053. If you find the logarithm of 84, 80, and the next one 4, then it's 9053. And the logarithm of 1256 is 990. And now after that we have to subtract and we have to find the antilog of the rest. If you find the antilog, you will get 64 directly as the answer. Then r to the power 3 is equal 64, and by using the value obtained above for r to the power 3, find the radius of the sphere. Then r is equals just 4, because you can see that 4 into 4 is equals to 64 centimeter. Solid cone of base is radius simple r and height 12 centimeters. So you can see that the base is simple r and the height is 12 centimeter, is kept in a cylindrical vessel of same height. Height is same, right? No, the cylinder also, it's 12 and the radius is 2r. The cylinder is filled with water. Okay, right. So the cylinder is filled with water, not inside the cone. Okay, the cylinder is filled with water such that the cone is fully sink in water. Okay, you can see that now. Find the volume of cone in terms of phi and r. So how to find the volume of the cone? Here the formula 103 phi r squared h, and 103 phi, just let it be, and the radius of the cone is r and the height is 12. So I substitute them, and now 3 to 12 we can cancel, and that's 4, and 4 phi r squared is the answer. Show that the volume of water in cylinder is 44 phi r squared. So how to calculate the volume of the water? That means the remaining volume, right? So for that, what we have to do, we have to find the volume of the cylinder and we have to find the volume of the cone, and just we have to subtract them. That's what I have done here. The difference of the volume of the cylinder and the volume of the cone. So volume of the cylinder, now we'll try to find out that. The formula is 5r squared h. Already 5 is there. And the radius is 2r. So 2r squared and into the height is 12. So 2 squared it's 4. 12 4 is 48 5r squared minus 4 5r squared. Now if we subtract, we will get the answer as 44 5r squared. And the third one. Which height does the water level drop down when the cone is taken out from the vessel? Okay, so they are asking if the cone is taken out, then what's the height of the water level? Okay, so to calculate that, the area is same. The area of that water level is, the water is same, right now, as well as it's take the cylindrical shape. So we'll go with that. Volume of the water is equals to area of the base, the same base, and into height. We don't know the height. That's what they're asking us to find out. And we have the volume of the water, and that's 44 5r squared, and area of the base is 5r squared itself, and 5, and this time the radius again it's 2r squared. So 2 squared is 4 5r squared. Now to subject this h, we'll take this to the left side, and there will be division 4 5r squared. Now we can cancel them. 4 5 to 5, r squared to r squared. 44 divided by 4, the answer is 11 centimeter. And here the next one, this is also not much difficult. So you all can see that a paper weight is shown in the diagram. It's made by removing a right circular cone symmetrically from a hemispherical solid object. Okay, right, so you all can see that a paper weight is shown in the diagram. Okay, it is made by removing a right circular cone symmetrically from a hemispherical solid object diameter, and the diameter of the hemisphere is 14 centimeter. The diameter is 14 means the radius is 7. Diameter of the bottom of the cone is equal to the radius of the hemisphere. So the radius of the hemisphere is 7. So this one also 7. Then the radius of the cone is half of that. So 7 divided by 2, it's 3.5. Find the diameter of the bottom of the cone, that's 7 centimeter. And what's the height of the cone? The height of the cone is equal to the radius of the hemisphere itself, right now, because all the radius are same. Okay, radius of the same sphere. So directly we can mark that as 7. And now calculate the volume of the paper weight. For that we have to go with this formula, volume of the hemisphere, and we have to subtract that by the volume of the cone. In the previous question also we did the same thing. So the volume of the hemisphere is equals to 4 over 3 phi r to the power 3. 4 over 3 phi r cube. That's the formula, right? So 4 over 3 let it be. And the value of phi is 20 over 7. And r of the hemisphere is 7. Then 7 to the power 3. So now we can cancel them 4 to 4. And that's it. 4 into 22 is 88. 7 sevens are 49 and over 3. And now we'll go to the right side. 103 5 means still 20 over 7. And the radius of the cone is 7 over 2. And the height is 5r squared h. 103 5r squared h. So the height is 7. So now we'll simplify them. 7 to 7 can cut. 2 to 2 to 11. Okay, so 11 just let it be. 7 sevens are 49 and 3 twos are it's 6 itself. Okay, right. So here the common denominator of these both is 6. So I wrote that the LCM is 6. So for that what we have to do is we have to multiply the first term by 2. So that's what I have done here. And now you all can see that the 49, the term 49 is common. So I took that out and I wrote the rest inside the bracket. 88 twos are 176 minus 11. So 176 minus 11, the answer is 165. Now we'll multiply them both, then 8085, and if you want you can write this in a mixed number. And here the last question. A cylindrical vessel with 7 cm radius and 42 cm height is full of ice cream. Calculate the volume of the ice cream in terms of phi. Okay, so the first question is calculate the volume of the ice cream in terms of phi. Okay, so we'll see. The cylinder is with radius 7 and the height 42. So we'll apply that. Phi, they are asking us to in terms of phi. So don't go to substitute that value, right? So let it be. Phi means phi and r is 7 into 7 and the height is 42. 7 sevens are 49, 49, 42s are 2058 phi. Just let it be. And the next one. Entire ice cream was poured into a number of hemispherical ice cream cups with radius 3.5 centimeter. So 3.5 centimeter means we'll go with 7 over 2. Show that the volume of one cup is 1372 over 48.5. That's easy. The entire ice cream cup was poured. Just they're asking. They have given the radius, so I mark that 7 over 2. And hemisphere means just half of that. That's it. That's the question, right? That's all. So 4 over 3 phi r cube. 4 over 3 phi r cube, that's a common formula, and we have to multiply that by half because it's a hemisphere. Now we'll simplify. 2 to 4 we can cancel, then it's 2, then 2 over 3 phi, 7 to the power 3, it's 343 over 8. Now we can cancel them further, but I'm going to multiply that. 2 into 343 is 686, and over 3 8 it's 24, but they're asking us to get this answer, so for that I'm going to multiply them both by 2. Equivalent fractions. So the answer is 1372 over 48.5. That's it.